What's up, guys? I put this off as long as I could, this assignment here. You're graphing exponent functions. These will not be lines. You do not need a ruler, okay? The reason why it's not a linear, it's exponential, because you got 4 to the x power, okay? So that tells you right there it's going to be an exponent function. Really, the only way to do an exponent function is to set your input-output table. You're not doing MB, that's for linears, okay? If it was 4 times x, darn right it'd be doing the MB, but it's not, so it's 4 to the x power. So I would suggest you go 2, 1, 0, negative 1, negative 2. Now, I'm going to do these first 4 the long way, then we're going to discover maybe a quicker, more efficient method, okay? So what I want you to do is write 4 to the x power on a piece of scratch paper. First thing I want you to do is just put a 2 in for the x. Well, that one's equal to, because it's whatever 4 times itself is, 16. So this is 16. Now I'm going to put 1 in for x, so it'll be 4 to the 1 power, and that's 4. Okay. I'm going to put 0 in for x. Anything to the 0 power is 1. Okay. Now I put negative 1. Now remember how we deal with a simple negative exponent. Okay. If you put a 1 over it, you can make it positive. So 4 to the 1 is 4, so it's 1/4. Now, negative 2, so 4 to the negative 2 power, 1 over it can make it positive, and it's 1/16. Okay? A negative output is not possible. Okay? All it does is it just gets infinitely larger that way, and it just gets infinitely smaller, but smaller in meaning that it just gets really, you get these really insanely small fractions, 1/16. Okay? Now, here's how you want to graph this, okay? Now, your x is this one, so you just have to, the x I'm not going to label, because everybody knows where 2's at, where negative 2's at. But on the y's, we have to get to 16. Well, going by 1's is not possible, okay? 16's the highest. So, going to go by 2's. If 2's don't work, you're going to go 5's. Look what I have on the board. 1's don't work, do 2's. Then 5's, 10's, keep it easy. Okay? And then we can go by 20's if that fails. Okay? 1, 5, 10, 20. Okay, so we'd have to go by 2's. 2, 4, 6, 8, 10, 12, 14, 16. So 2, 4, 6, 8, 10, 12, 14, 16. Now you graph them. So 2/16, I go to 2. You can still have this one be worth 1's, okay? Just because you're going by 2's here, you can still be going by 1's here. So 2/16, okay? 1/4, so I go to 1/4. 0, 1, now remember you're going by 2's, so 1's here. Now here's how you do these fractions. It's really easy. You just go negative 1 and then just a little bit, and then negative 2, just even teenier bit up. Okay, so you're pretty much up against the line. Now all the inputs this way just make my output insanely high. All the inputs this way just take the output closer and closer to 0, but you don't cross the line. You never cross the x-axis. There is no x-intercept. Okay, that's the graph, arrows on each end. Okay, next one. There is a quicker way to do this. Okay. 2, 1, 0, negative 1, negative 2. So on your scratch paper, just put negative 1/5 to the x power. So first you're going to, and it's a caret. Okay. So now first you're going to put 2 in. 1/5 caret 2. All that is taking 1/5 times 1/5, and you just times 1 by 1, 1, 5 times 5 is 25. So 1/25. Now put 1/5 caret 1. Well, that's just 1/5, okay? Now I don't care if the base is a fraction. If it's to the 0 power, it's a 1, okay? Now do -1. Now, so I want you to look at something right here, okay? So let's look at this, -1 with a fraction. So you're like, what do I put a 1 over the fraction? No, you don't. When you have a negative exponent, you can flip it and make it positive if you flip it. So it'd be 5 over 1. But 5 over 1 is just 5, okay? So 5 to the first power would just be 5. You ever notice how these are just reciprocals? So 1 over 25, 1/5, 5, 1. And then now if I put -2 in, I'm not going to put a 1 over it. So now I write it without the 1. I just flip it to 5 over 1. Okay, and then it's +2. Now the 1 on the bottom you don't need. If you have a 1 on the bottom, it doesn't matter. So 5 to the second means 5 times 5, and it's 25. Now, you got to get to 25. That's your highest, okay? This can go by 1s and 2s. So again, the negative exponent, you essentially, if it's a whole number, you put a 1 over it. But if it's a fraction, you just flip the fraction, and then it can become positive. Okay. Okay, let's do the 25 first. Okay, I always do the fractions last. Do your fractions last. Just start down here. Graph this one first. Because on the y-axis, we're going to get to 25. So I'm not going to be able to go by 2's either. So now I go by 5's. 5, 10, 15, 20, 25. Okay, so graph this one first because I know where 25's at. So -2, 25. So I go 2, 25. -1, 5. 0, 1. Remember, 1, you're going by 5, so 1's there. Now with these fractions, they just get closer and closer to the middle. They never cross it. Okay, that's why you probably want to graph your whole numbers first. Start at the side of the table that's got the whole numbers. Just trust me on that. Okay, so we get insanely high this way. Right there, you just get closer to the x-axis. Now, the reason why this is going up and this is going the other way is because the base of the exponent's 4. 4 is bigger than 1, so that's growth. So it means it's growing this way. This is decay because the base is less than 1 whole. Okay, y equals -2 to the 1/3 to the x power. Okay. Now set up your table. 2, 1, 0, -1, -2. And just focus on the power. We'll worry about the -2 last, okay? So on my scratch paper, I put 1/3 in parentheses to the x power. Now I'm going to put 2 in, okay? So 1/3 of the second is just 1/3 times 1/3. So that's 1 over 9, okay? 1 over 9. Sorry, it looks like crap. 1 over 9. Okay, now put a 1 in. Okay. That's just 1/3. Okay, if it's the power of 1, it just ends up as the base. Now, anything to the 0 power, doesn't matter if it's a fraction or not, is 1. Okay. Now we do our negatives. Okay. So 1/3 to the -1 power. Now you can make it positive if you flip the fraction to 3 over 1. Okay. Now if I have a 1 on bottom and I can make it positive now, I don't need the 1. 3 to the first is 3. So I want you to notice a pattern. When you did 1, you got 1/3. When you did -1, you got 3. If you got 1/9 here, you're probably going to get 9 without the 1 here. Okay. I mean, I'm just saying. Let's show. Okay. Okay, positive as long as you flip these switch places. So 3 to the second, that's going to be 9. I don't need the 1 on the bottom. 1 to the second is just 1 anyway, so it's 9. Okay, just like I've anticipated. Now about this -2, what you're going to do is times all of these numbers by -2. All you do is take all your outputs times -2. So 1/9 times negative 2. If you're not good with fractions, use a calculator. It's going to be negative 2/9. Circle it. 1/3 times negative 2. It's going to be negative 2/3. Okay. 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. 9 times negative 2 is negative 18. Now you got to get to negative 18. You're always going to go 1, 2, negative 1, negative 2. Now we got to get to negative 18, but we're going to label the down part because it's negative. So we can't go 2, 4, 6, 8, 10, 12. Can't do that, so let's go by 5s. Negative 5, negative 10, negative 15, and negative 20. So start with the non-fractions. So go left 2, go to negative 2, then 18's right there. Okay. Negative 1, negative 6. Okay. 0, negative 2. And then all you do, you're still in the negatives, you're just getting closer to the x-axis. Now having a negative multiplier then makes it go upside down. It makes it negative. So it flat lines that way, and then it goes infinitely higher that way. Okay, last problem, then I'm going to show you the quick way to do it. You don't even need scratch paper. 5 times 2 to the x. So just worry about the base and the exponent. We'll times by 5 after it, okay? So 2 to the x. First we're going to put in 2. Well, that's easy. That's 4. 2 times itself is 4. So if that's 4, this is going to be 1/4 here. Okay, all it does with a negative exponent is it does not make it negative. It doesn't. It just switches. It just reciprocates it. Okay, then 2 to the 1. That's 2. So it's 2. So you know that the negative one is going to give you the reciprocal 1/2. Okay, and then anything to the 0 power is 1. Now times them all by 5. So 4 times 5 is 20. 2 times 5 is 10. 5. 1/2 times 5 is 2.5. And then 1/4 times 5 gives us 1/4. Now you're ready to graph. Okay. Start where you don't have the fractions. You have to get up to 20. Okay, so I can't, probably 5s. So 220, 110, 0's up at 5, and all you do here is you just shrink closer to the axis, okay? But you never change sides, okay? It just gets infinitely smaller. Now let's develop a quicker method to do this, okay? This is going to take about 5 minutes. If all you're doing is an input-output table, just use a calculator. 5 caret 2, 25. 5 caret 1, 5. That's 1. 5 caret negative 1. I don't care if you get decimals on fractions, that's fine. Okay. So it's going to be 0.2. Because that's 1/5 as a decimal. Okay. 5 caret negative 2, 0.04. That's 1/25 as a decimal, okay? But you never get into the negatives, okay? So start at the non-decimals right there. That's where I'd start because I know 25 is a solid number. So 5, 10, if you're going positive, so go 2, 25, 1, 5, 0, 1, and then all we do is get closer to the axis. You're like, how come you got fractions when you did it the long way? Because those fractions can be written as decimals, okay? So up that way, and here you don't go down, you just level out, okay? Next one, xy. 2, 1, 0, negative 1, negative 2. So I go 1 ABC 2 times, you got to get your parentheses, 1 ABC 7, close it to the power, hit your caret button with 2. 1/98 Now, here's what you can do. You don't even need to clear the thing. You click the up arrow on your compass, and instead of the caret 2, you can just put a caret 1. You just put a 1 over the 2. Put your cursor on the 2 like that. 1/14. Okay. Zero. It's going to be 1/2. Now you're like, I thought that was always 1. Well, yeah, that to the 0 is 1, but times 1/2 is still 1/2. Okay. Now, when you go into the negatives, here's what you need to do. You need to go over that just like you did before and go -1. Okay, you got to hit the -1. Okay, so it's going to be 3.5. Caret, put your cursor, you still want the negative in there. Okay, and now I put 2 in. 24.5. Okay, these really small fractions, I don't start here. I'm going to start right there with the 24.5. Okay, so I'll do the -2 first. Go with the more extreme part. 24.5, I mean that's close to 25. We're probably going to have to go by 5s. -2, 24.5. You just go -2 and then just slightly below the 25. It's pretty easy. Okay. -1, 3.5. 3.5 somewhere in there. Then all that happens this way is we just get closer and closer to the x-axis, never crossing it. So they're hooks. Okay, y equals -4 to the 6. If you have a negative multiplier, they're all going to be down here. Okay, guaranteed. Because yeah, 6 to any power is positive, but multiplying it by -4 takes it negative. 2, 1, 0, -1. That's me putting positives. So I got -4 times 6, caret 2, -144. Oofda. Click up, instead of caret 2, you want caret 1 now. It's -24. The 6 of first is 6 times -4 is -24. Caret 0, -4. Caret, just go over that 0 and go -1. -0.66, just you don't need to put the repeater. Okay. Round it somehow. 2, -0.11. Now if you're like, oh, but those aren't reciprocals, no, they're not, because you had a multiplier. Okay. Alright, got to go to -144. So we're going to label downward, they're all negative. Okay, so 20s, 20, 40, 60, 80, 100. You can go 20s. Okay, 20, -40, -60, -80, -100, -1, 20, -140, -160. So I'm going to start at 2. Again, start where you have the most extreme. Don't do those little small decimals. It's a pain. So 1, -24, and 0, -4, right there. Okay, so again, they're all negative because you have that negative multiplying number. Because taking positive times a negative is always going to result in a negative. Okay, y equals 3 times 1/2 to the x power. You got to get the parentheses if there are any. Okay, so 3 times parentheses 1/2, because if you don't put the parentheses, then because we need the whole 1/2 to the second. Because if you don't put parentheses, it's just going to take the 2 to the second. 3/4. Click up, the up arrow on the compass. Now go over your 2 and put 1. So 1 and 1/2. This is not 1 because you have the, it's going to be 3 because that's 1 times 3 is 3, I guarantee it. Anything at 0 power is 1, but since we're timesing by 3, it's 3. -1, 6. Because that would be 2 over 1 to the first power, which is 2 times 3 is 6. Because with negatives, remember when I was doing it the long way, I flipped them, so it'd be 2 to the first. Okay. 2. Make a prediction here. If you have a negative power, that's 2 to the positive, 2 over 1 to the positive second, so 2 to the second's 4 times 3 is 12. Okay. Probably got to go by 2's. Okay. You can hit 12 by 2's. You're going up, though, because all your y's are positives. So, do this first, negative 2, 12. You want to start where you got the most extreme. Okay. Negative 1, 6. 0, 3. 1, 1.5, that's just right there. And then the 2, all you do is just get close to the line, okay? Never crossing it, though. Okay, that's it.